object like this that has a lot of forces acting on it, and you're trying to predict its motion, right? We're trying to predict what's going to happen with it. Then you need to invoke Newton's second law, which says the sum of the forces equals the mass times acceleration. That's the whole point of doing free body diagrams, is try to make a prediction. And here's my skier over here, and I just went ahead and did this for you so that you would have these forces, and I wanted you to think about the weight x component and the y component. In this free body diagram, have not defined the coordinate system, but I've given you a hint here. And that is to remind you that the best way to deal with this is to make the y perpendicular to the ramp and the x parallel to the ramp. If you do that, then your life becomes much simpler, because this free body diagram then rotates and it looks like this, that the normal force is facing up and the weight, oh, I need a better 10, is facing to the side. And now we don't have to decompose the normal force, we have to decompose weight. And that's cool because Letta told us to memorize that, right? Yes. And again, it's all about making your lives easier. Could you do it the other way? You could, but then you're going to have to figure out the similar triangles. And honestly, I don't want to do geometry on a physics test, right? And so this is mg. And we've said that this component, this is the y direction. And by the way, in the y direction, do we expect there to be accelerated motion or uniform motion? Should be uniform, right? We're not talking about it bouncing along the ramp. So this is uniform motion. And in the x direction, and I expect it to accelerate in that direction, so I'm going to call that my positive direction. We expect it to accelerate, and so that's uniform accelerated motion, right? So if you do it this way, then when you go to do Newton's second law, it's a little bit easier. All right, so if I'm trying to figure out her acceleration, remember the sum of the forces, well, which direction is she going to accelerate, the x or the y? The x direction is equal to mass times acceleration in the x direction. And we have to think about what are the forces acting on her in the x direction. So how many forces does she have acting on her in the x direction? Just one, the x component of her weight. Yes, the x component of her weight. And we've memorized, because we know it's just easier to memorize, that when you have something like this, and we know theta, there's theta right there, that the x component, so is mg sine theta. We memorize this because we don't want to have to do geometry on the test, and that the y component is mg cosine theta, right? We've all memorized this? Please tell me we've memorized it. Just makes your lives easier. And so now there's only one force acting on her. That's the x component of the weight, right? And that x component is mg sine theta, which equals mass times acceleration. And it's essentially supported free fall. That's why what doesn't matter? Mass doesn't matter. Right? So mass doesn't matter, so you can cancel that out, and you get that the acceleration is g sine theta. Theta is 25 degrees, right? And what's our answer, guys? What's our answer? 4.2. Exactly.